hopefully you're enjoying your nice 3-day weekend right now. Thank you for tuning in on your weekend. Hopefully it's your weekend. You're doing 7B, normal curve. Normal curve. Probably talked about it in either AFTA, if you took that class last year, or in Algebra 1. Nevertheless, you don't really need to know a lot about it. I'll explain it, and hopefully you can follow. For 7B with normal curve, you're supposed to be able to identify properties of a normal distribution and apply those properties to determine the probabilities associated with areas under a standard normal curve. That's a lot of stuff. When I show you the examples, it should make a lot of sense. You might have heard of a bell curve in your life. What is a bell curve? A lot of times we talk about it with grades. The example I have right here is adding up, when you roll 5 dice, adding up the totals. Well, if you keep on rolling 5 dice, eventually it's going to give you a normal distribution, meaning there's not going to be many 5s. Like, you got that roll all once to get 5. So not very many, almost a 0% chance, just a little bit above it. And 6, just a little bit more, 7, a little bit higher, 8, a little higher, 9, and eventually the number that's going to be the most is 17. You're going to roll 17s more than anything else with 5 dice. So if you actually followed, so this is where all the data rolled 5 dice thousands of times. This is, it would follow this curve. And if you drew a line right above all the tops, you should be seeing a bell-shaped curve. So underneath, if you look at the red line, that's a bell-shaped curve. That's why we call it a bell curve. It's also called a normal curve. Normal meaning in the middle, the left side and the right side are exactly identical. They're very, very close. It's kind of the general term for normal curve. Let's get into some percentages. Standard normal curve. Since normal is standard, because every normal curve follows these percentages. And really the percentages you need to know are, this is one standard deviation, and the percentages to the left and to the right of the y-axis there is 34 and 34, together 68%. So 68% of the data is always within one standard deviation of the mean. Now you don't have to know standard deviation right now, so just one standard deviation of the mean is 68%. If you go 2 standard deviations away from the mean, the number that you have to remember, we'll just say it, we're going to round it. We're going to round it to 95%. 95% is 2 standard deviations away from the mean. So that means 2 standard deviations to the left and 2 standard deviations to the right. So within. So we're talking between 2 points. Well, I guess we're looking for D police. Hear that? Another number you need to know, 3 standard deviations. So from here to here, 99%, actually 0.7% of whatever I'm surveying, whatever I'm looking for, 99.7% of all the data is going to lie within 3 standard deviations of the mean. So if we go back to the example here, the mean is the average, so that's right here. So it's talking 68% of the rolls. 68% of the rolls will be within 1 standard deviation. That's without doing any math, I'm just kind of guessing here. We'll actually do some math later. So we'll say right in there, that's 1 standard deviation of the mean, left and right. 2 standard deviations, that's 95% of the data. So that's between this point here and somewhere out here is about 95% of the data. And then 99.7, that's almost all the data. So that's like way out here to way out here. That's 99. It's almost 100% of the data, which is all of the data. So let's go into an example here. You know that it's normally distributed, so we don't have to know anything about, you don't have to look at the curve. And this, well, I guess we actually have to draw this curve. So the normal distribution, so this would be a bell curve, mean of 37. So when I draw this picture, it's normal curve, so just draw an upside down bell shaped. And the mean is always in the middle, so mean of 37, so put 37 there. And a standard deviation of 8.1. Sketch normal curve for the distribution labeled x-axis, well here's the x-axis. And values at 1, 2, and 3 standard deviations from the mean. So what we do is we're going to take the 8.1, and we're going to go 1 standard deviation away from the mean. So if we take 37 and add 8.1, that's going to give me 45.1. So we're going to estimate where 45.1 might be on a number line, x-axis, it's going to be to the right. That's 1 standard deviation above the mean. Now if I take 37 and subtract standard deviation away, that is 28.9, so that's going to be below 37. And now that is 1 standard deviation away from the mean, which is where 68%, you got to remember 68% of the data is within this. That's 1 standard deviation. If I go 2 standard deviations away, this is already up, so I'm going to take 28.9, and I'm going to subtract another 8.1. So that's taking another standard deviation away from the mean, which is 20.8. So we'll again draw a line. Just estimating here. I'm not doing anything very, very accurate on this drawing, but with the drawing, it doesn't really matter. I'm adding 8.1 to 45.1, which is 45.1 is already 1 standard deviation away from the mean, so now I'm going to add another standard deviation away to get 53.2. And then, so that's 2 standard deviations away, and then we got to do 1 more standard deviation. So since I already have it up, we have 53.2 plus another 8.1, 61.3. If I take 20.8 and subtract 8.1, it gives me 12.7. So right here it's sketched. 37 is the mean. We have 1 standard deviation between 28.9 and 45.1, 2, 20.8, 53.2, and 12.7 to 61.3, whatever we're talking about here. If it's height or weight, these are standard deviations. Here's another problem, another example that you might see. Set of data has normal distribution with a mean of 29 and a standard deviation of 4. Find the percent of data within each interval. So this now we're actually going to start using the calculator to find standard deviation. So to find this, we go to, we have second VARs, second VARs, VARs. And we're going to use normal CDF. There's PDF and CDF. We never use PDF. We always use CDF. C for correct. Not really, but that's one way to remember it. Normal CDF for correct. We're going to use that correct one. Some of your calculators will look like this. Some of the calculators will actually write out the next steps, what needs to be. But now, what we need to enter in here is we need to enter in the lowest possible number, the highest possible number, the mean, and the standard deviation. Well, the lowest number is we're doing from 25 to 33. If we start with this example, that's the low is 25. That's the lowest number. Highest number is 33. And then the standard deviation is 4. Or mean first, mean, and then standard deviation. So what we're going to do is we're just going to enter this into the calculator. When I enter it in the calculator, you always go low first, comma, right above the 7, high number, comma, the mean, comma, and standard deviation. Close out the parenthesis, and it comes up with 0.68. We're going to round the 2 to 3. We want a percent here, so this is decimal, so we go with this percent, 68.3% of the data, whatever we're talking about here, will lie between 25 and 33. 25 and 33 could refer to weight of something, or the number of sometimes something occurred. Moving on. I'm going to do greater than 29. So in this case, greater than 29, we have greater than 29. If you're looking at a number line, 29 is going to be the lowest number. What's the greatest number? Well, there isn't one. So we're going to say high. To trick the calculator, we're going to trick it. We're going to put in a lot of 9s. And 7. Good enough. Put in a lot of 9s. That's a really high number. Again, standard deviation, that's 4. Mean is 29. So we just enter it in the same way. Second, bars, normal CDF. You go the lowest, 29. Highest, 1, 2, 3, 4, 5, 6, 7. You can put 8, 9, doesn't matter. Put a big number in. And then it's mean and standard deviation. Enter. And you get 49, looks like about, I will round that to 50%. So 50% of the data, which makes sense. If the mean is 29, half the data has to be above the mean. Mean is in the middle. Mean is also in a standard deviation or a normal curve. Mean is the same thing as mode, it's the same thing as median. So if it's the mean, it has to be in the middle. For less than here, probably not going to put this in the calculator, but our lowest, less than 21, this Terrence, say 21. We have 21 is the high number. Less than, well, we don't know what number it's we're talking about here. So unless it talks real life data, we could write, you can go 0 or really, really, really big small number. It's a really small number. That's your low for this case. But I'm not going to waste your time. You guys will know how to do that. Alright, so take your time, read this problem. This is one SOL question that you might have this year. Heights of 200 kindergarten students. You guys can read. Let's see here, let's start gathering some data. We have, let's see, the mean of 40. Standard deviation, 1.8. And I see between 37.3 and 44.5. I got to figure out how many students are between these two. So 37.3 is the low number, 44.5 is the high number. And when I enter this in the calculator, I'll get back to you in a second. I'm just going to put it in the calculator. Okay, so it's in the calculator. I got 0.926983, you can read. This is a decimal form of the percent. If you read the problem, you want to know how many students. This is a percent of the students, or decimal form of the percent. If I want to actually find the number of students, there are 200 kindergartners total. We want to know how many of them fall between 37.3 and 44.5. Well, we have a percent of those that fall between those. We have right here in the calculator. If I take that percent, it's a multiplication by 200, I'm multiplying by 200, that'll tell me how many students. So approximately 185. So 185 students will be between 37.3 inches and 44.5 inches. Come to class with some questions about this. We're going to be using the calculator quite a bit. One last tip. So remember how to put it into the calculator for the lowest, the highest, middle, and standard, or mean and standard deviation. Last year, some of my students came up with Lee High Middle School. Oh, that's C. This is, if you just remember Lee High Middle School, you remember low. That's really the low. This is the high number. This is the mean, middle, and school is just standard deviation. Just a little device to help you remember, hopefully, which order to write it in the calculator. All right, come with questions. Remember, you have a test coming up, a retake of the test. Study, study, study. All right, enjoy.